All right, so I am going to have notes out for the sub that she gets to go around and check this off for you. Notice you can use your lab sheets if you like. You need to get a large whiteboard and a marker and show me that you know the parts of a wave. You are being timed. If you get done before the time, have your hand up and the sub will come over and tell you if you're right or not. All right, by now you should be done. And we're going to go to the next one. So, two waves, one having twice the frequency of the other. They need to be on top of each other, superimposed. Do not make one line and change it. It needs to be two separate lines, one on top of the other. And for the second one, I want another set of waves also on top of each other, but one has 3 times the amplitude of the other, identical frequencies. Once you're approved or you've done it right, make sure your board's clean and put it back. And I need you to see what you notice. You could look at your data tables on your labs. What do you notice about wavelength versus frequency? All right, so someone from table 6 up front here. What's the relationship between wavelength and frequency? Okay, there is a math term for that answer. It starts with an I. And you should have noticed that if one goes up, the other goes down. And we call that an inverse relationship in science and in math. All right, on this, we just need to make sure, first of all, we're going to have you turn them in. So whoever has the most pets is the walker-upper for this assignment. I need 2 piles, put them in the folder. Okay, make sure they're separate by, you know, the FET versus the Slinky lab. Make sure they're separated. Everyone else start getting out your notes, because I'm going to be going over this stuff here. Wavelength, you know, everyone pretty much got that. This symbol is the Greek letter lambda. Yes, it looks a little bit like an upside down Y. One year I had a group of kids who said it looked like a stick-figured dinosaur. Whatever. Okay, but that's the Greek letter lambda. It is this, takes the spot in the equation. It is not the unit. So I don't want to see any upside down Y's behind a number. Okay, the wavelength is not 1600 lambda. It'd be 1600 meters. Frequency, remember this is the day we did the SNAP thing. This is measured in hertz. That's the full name. We abbreviated Hz. This is number of things that happen per second. Okay, velocity with the other two. This is the equation that you have to know for this chapter. Velocity is equal to the frequency multiplied by the wavelength. Velocity of a wave is measured in meters per second. So if they give you a wavelength in kilometers, you have to turn it into meters. Amplitude, as opposed to just saying it's the distance above the rest position, think about what variable that would entail. If you were going to swing the slinky so that you had an amplitude of 3 squares on the floor compared to swinging the slinky so that you had an amplitude of only 1 square on the floor, which one takes more energy? All right, so if you're going to have a big amplitude, that's really a measure of the energy in the wave. Little waves of water don't hurt you. Giant typhoon-sized tsunami waves, those hurt you because that's a tall wave. When we get to sound, the idea of amp and amplitude, guys have amps so that they can have their electric guitar be really loud. The more power their amplifier has, the bigger the energy, the more energy it takes, because it usually uses more watts, the louder the sound. So it's a measure of energy in the wave. The period, by definition, is the inverse of frequency, and you're kind of like, well, that's why. Here's why. 30 hertz means that 30 waves go by you in a second. Okay, so the inverse of this would be 1 over 30, but what does that mean? Okay, now all of you should have a calculator, and this is where you need to dig your calculator out and look for one of these two buttons, either 1 to the x to the negative 1 or 1 over x. These are what we call your inverse button. Okay. Now that you found it, take 30, hit the inverse button, and what do you find out? All right. That means if the wave has a frequency of 30 hertz, that means the time for one single wave to pass by you only takes 3/100ths of a second. The second is the standard. We know we're counting how many things pass you in 1 second. The period tells you how long it takes one wave to go by you. Okay, so that's the difference. So you want to be sure that when you're reading a problem, are they telling you how many waves per second, or are they telling you how long it takes a single wave to go by you? Because frequency is what's in the equation, not the period. Now you need to go find the book. In chapter 18, there's a nifty picture somewhere on the right side. See if you can find it on the right-hand side of the book. What is the difference between AM and FM? When you find it, just chill a little bit, because some people are a little slower at finding stuff in a book than others. Okay, so AM, table 2. What does this mean we're changing when we says amplitude modulated? Right, so it's amount of energy, and okay, not to totally disrupt the class, but I thought everyone had done this before when you're kids, but when you like make a noise and then beat yourself on the chest, like that, and it makes funny noises, and okay.